Good morning, thank you for joining us, and today we'll be looking at linear equations, as well as linear equations with brackets. So our basic linear equations, when we're looking at algebraic equations, we'll have something like 5x minus 24 is equal to 2x plus 12. And when it comes to our linear equations with brackets, we'll have something that looks like 2 open brackets 3x plus 1 is equal to 7 minus 4x. Okay, so a clear example, it's in the name. First linear equation is going to be a basic linear equation, right? Our second one with brackets is going to include some brackets, where obviously we apply our rule of timesing the outside term into the first term in the bracket and then into the second term right after. Okay, and of course we always know that when we are busy with linear equations like this, we're going to be looking for our like terms, specifically the terms that include variables like 5x over here and 2x over here, and then of course our constants, negative 24 and positive 12. So we know the first thing we need to do is to have our letters on the one side and our numbers on the other side. So if you can see here, we have 5x on this side over here. So we're going to bring 2x over to the left hand side. And then we're going to bring 24 over to the right hand side. But remember, when we are bringing things over the equal sign, we are changing the sign in front of the number or the variable with the number. Okay, so what's going to happen is 5x is going to stay on the side. When 2x is coming over, you know the sign changes to negative 2x. Then we have 12 on this side. You know that when the 24 goes over, it becomes positive 24. So now we can, because these are like terms on both sides, you know we can freely add or subtract. So we're going to go 5x minus 2x is equal to 3x. And then that's equal to 12 plus 24, which is 36. Now we're left with one term on both sides of the equal sign. But you can see x right now is not by itself, and remember we have to try our best to get x by itself. So we can do 3x divided by 3 to get rid of that 3. Now what we do to the one side, we remember we do to the other side as well. So 3 cancels out with each other over there. So we're left with x on this side. And then now we have 36 over 3. It's basically 36 divided by 3. So then we'll get x is equal to 12. Coming over to our brackets example, if we look at this, so we're going to start by doing 2 times 3x and 2 times 1. So we're going to times outer bracket first. We're going to start with that every time, okay? So we have 2 times 3x is equal to 6x. And then 2 times 1, which is equal to 2. So that's equal to 7 minus 4x. Again, we're going to look for our term with the variable. Then we're going to look for our term, our constant term. It's positive 2. And then 7. Okay, now we're going to bring our variables to the left and our constant to the right. So we have 6x. The 4x will come over as we do now. So it'll become positive 4x. And then we'll have 7 left over here. And then 2 will come over to become negative 2. So now if we're going to do this, it's going to be 6x plus 4x is equal to 10x, which is equal to 7 minus 2, which would be, sorry, let me just write in the answer rather. 7 minus 2, which is 5. So if we're going to do this now, it's going to be divided by 10 to get rid of the 10, because we want to get x by itself. So the 10s are going to cancel out each other. So we're left with x. And then on this side, we have 5 over 10. So what we're going to be left over with is a half. Right? Because we have to simplify our fraction, because we can't leave it as 5 over 10. So how do we do that? We find the highest common factor between 5 and 10, which would be 5. So then we divide 5 by 5 and then 10 by 5. So we get 1 over 2. Okay, so now we're going to look at some other examples now of linear equations and ones with brackets. So for the next one we'll be looking at 18 minus 5x is equal to 2x minus 9 minus x. Okay, so let's have a look at it here quickly. We now, first step, we're looking at like terms first. So we have negative 5x, we have 2x, and we have negative x. Then we also have 18, and we have negative 9. So I want to bring my letters over to the left hand side. So all of my letters can go to the left. We're going to have negative 5x over here. Then we're going to have, when the 2x comes over, it's going to become negative 2x. And the negative x comes over, it's going to be positive x. That's equal to negative 9. The 18 is going to come over, it becomes negative 18. So now if we're going to look at this, we have negative 5x minus 2x, negative 7x, plus x, which is equal to negative 6x. And now we have negative 9 minus 18. So that will equal to negative 27. So now what we need to do is we need to get x by itself. So we're going to divide by. So we can see that if we just divide by 6, we'll be left with negative x. So we don't want to be left over with negative x. So we'll divide by negative 6. So that x can be left as a positive, because remember, a negative divided by a negative will equal a positive. So now negative 27 is, we have to divide by negative 6 as well, because what we do to the one side we need to do the other side. So now we'll be left over with a regular x on this side. And now on this side we have obviously a negative divided by a negative. We know it's going to be a positive, but we have to simplify this fraction still. And how are we going to do that? We need to look at highest common factor. Now if I try and look at the highest common factor between 6 and 27, it is going to be 3. Right? So I'm going to divide 27 by 3, I'm going to get 9. And if I'm going to divide 6 by 3, I'm going to get 2. So our final answer here is x is equal to 9 over 2. Now let's look at a brackets example. So if we can look at a brackets example, let's see, we got 7x plus 2 in brackets plus 2 is equal to negative 5 x minus 6 plus 2 5 minus 3x. So straight away we know our first step when we're dealing with the bracket linear equations, we're going to times out our brackets first. So firstly we're looking at 7 times x, 7 times 2. So we get 7x plus 14 plus 2 is equal to, going negative 5 times x, negative 5 times negative 6. So now negative 5 times x, it's positive times negative, so it will be negative 5x. Then we're looking negative 5 times negative 6. It's a negative times a negative, so we get a positive 30. Plus 2, sorry, my bad. The 2 is attached to the bracket, so we need to times the 2 into the bracket. So it's going to be 2 times 5, 2 times negative 3x. So the 2 times 5 is going to give us 10. And 2 times negative 3x is going to give us negative 6x. Now we're going to be looking at our like terms once again. We have 7x, negative 5x over here, negative 6x. And then we have positive 14, positive 12, positive 30, and positive 10. Again, now we're going to bring out our letters over to the left, numbers to the right. So we have 7x. This is going to be plus 5x and plus 6x. Right? And then we're going to bring out numbers over to the right. So we have 30 already here, plus 10x, minus 14, minus 2. So when we look at this, 7x plus 5x, 12x, plus 6x can give me 18x. 30 plus 10 is going to give us 40, minus 14 is going to give us 26, minus 2 is going to give us 24. So now what do we have to do? We have to divide by the highest common factor. So if you're going to look at this, between 18 and 24, the highest common factor we can see is going to be 6. So if we're going to divide by 6 on this side and 6 on this side, we're going to get 18 divided by 6 is going to give us 3x. So this is how we're going to start. We get 3x, and then we're going to get 4. So now we can just divide by 3 this time. So you can see I brought it down to a simpler number so that it's a bit easier to divide out. So we're just going to be left with now x is equal to 4 over 3. So important what I did here is I tried to look for the highest common factor between 18 and 24 so that I could bring it down to an easier number, right? I could have divided as well by 18 straight away. So if I divided by 18 straight away, I could have gotten x is equal to 24 over 18, right? Now again, I'm still going to look for the highest common factor, which would be 6. So then I would divide it by 6, get 4 over 3. So same answer, I just took 2 different routes. Okay, look at one more example of a linear equation, and we'll look at one more of linear equation with brackets. So in this example here, we're going to have x plus 1 is equal to x plus 1. So if we just going to do this one really quickly, we get x minus x because this x is coming over. Then we get equal to 1 minus 1 because the 1's coming over. Now you can see what's going to happen. We're going to get 0 is equal to 0. So it is very possible to come across an example like this. So what your answer would be once you get 0 is equal to 0, you'd say therefore x is an element of all real numbers, okay? An element of all real numbers. Sorry, let me just try and do this a bit better. So it looks like a double line, and then the R comes through like that, okay? And then for the brackets example, let me do this one as well just quickly. So you get given 2 times 3x plus 4 is equal to 3 times 2x minus 6. So what we're going to get is, and times into the brackets the 2, you get 6x plus 8 is equal to 6x minus 18. So now we're going to bring our numbers to the left, letters to the right. Our letters to the left, numbers to the right. 6x minus 6x is equal to negative 18 minus 8. Cool. So you'll see on the left hand side we're going to get 0. On the right hand side we're going to get negative 26. So in the case where we got to a point where x is equal to 0 over here, you can see we got 0, no x left over. We'll say therefore x has no solution. So these are just special cases that we could come across. There are two of them, where we get 0 is equal to 0, or we get 0 is equal to the number where x cancelled itself out before we got to the final answer. So the first one here, where 0 is equal to 0, x is the element of all real numbers, we write it like this. And then on the right hand side, where we get x cancelling itself out, x has no solution. Okay, that would be the end of the recording, guys. Thank you very much.